Hey, what's going on, guys? Welcome back to the channel. Welcome back to part 2 of the elevator lift here in the shop. I told you guys I'd give you a full breakdown of all the parts I use, materials, and pricing of everything it took to build this here. So let's get started with it. So first things first, I just want to say thank you to all you guys. Ever since I posted this video maybe a week or so ago, you guys have been great. A lot of new subscribers, so welcome to the channel. And a lot of great comments and suggestions and great feedback. A lot of positive feedback from all you guys on the lift here, so it was really good to see that. So if you guys didn't see the original video of the shop elevator here, I'll post a link up in the corner for you. Go ahead and watch that. There's a lot of good information there on how this all went together. So I will put everything in the description, all the links to all the products that I can source online for you. If you guys do use any of my links, it does help out the channel a little bit. So if you can use them, that's great. If not, it's no big deal. But let's get started and figure out what we had to buy for this thing. So the first thing, the main structure. If you guys remember, the first thing I started with was those 2x6s on the walls. Those were two 14-footers, 2x6s. They're about 10 bucks a piece. So I got 20 bucks into those. I put that LVL up top. Across the header there, that was a 12-foot LVL. It was a 11 7/8 tall, 1 3/4 thick, and that was right around 79 bucks, I believe. The unistrut you guys see coming down the wall there was 4 pieces of unistrut. So this is the 1 5/8 12 gauge unistrut. I ended up buying this at Home Depot. It comes in 10-foot lengths. I had to get 4 of them, and those were about $28 a piece. The steel tubing that makes up the frame here, this is all 1.5 inch steel tube. It's 1/8 inch thick wall tubing. I use that for the platform, the back rack section here. I ended up using about 50 feet of that, and I bought it local from a guy, and I think I spent around about 100 bucks. Underneath the carpet here is a piece of 3/4 inch subfloor, and I believe that was about 28 bucks for that. The brackets we used to connect the unistrut to the wall, these are Simpson strong tie brackets. I just bought these at Home Depot. Were about $4 a piece, and I ended up using 20 of them. There's 10 on each side going up and down. What connects the platform to the unistrut are these heavy duty trolleys. So if you guys can see, there's actually 3 bearings on each side that rides on the lip of the unistrut. There's a bearing at the top and bottom to keep the trolley from going side to side. So I have 4 of them. There's 1 on each side on the top, 1 on each side on the bottom. For the set of 4 of them was about $56. So there was some guys questioning the strength of the trolleys and the actual strut itself and wondering what it would take for these to pull out of there. These are actually rated for 3,000 pounds, not necessarily saying that the strut itself is rated for 3,000 pounds, but strut itself is rated for, I believe it's like 700 pounds at a 5-foot span. So like when they're hanging electrical equipment, you can hang 700 pounds on it with 5-foot spacing between your supports. You guys can correct me if I'm wrong, but I'm pretty sure that's what I read on that. We got supports every 24 inches. They're actually like every 22 inches. So we're plenty supported. And the way these trolleys work is there's actually 3 roller bearings like over a 6-inch span to spread out that load. So it's not all in just one little spot. But you guys also have to think, if stuff is somewhat centered on this platform, the load's actually divided up by 4. So your 2 cables in the back are holding 1/4 of the weight on each side. So that's half the weight's going to those 2 cables. And the other half of the weight is going up these chains to the trolleys that they were concerned about. So even if there was 1,000 pounds centered on here, that really only means there's 250 pounds in each corner and 250 pounds out here on the chain. But since these chains are at an angle, the load actually gets amplified a little bit. So if they're at a 45-degree angle, you would times it by 1.4. So your 250 pound load, might go up to 375 pounds, whatever it may be, pulling on this. So it's not that drastic. There's not that much load really on those bearings there on the strut. So even worst case scenario, you slid it all the way to the front and there was hardly any weight on the back, you might only be getting maybe 600 pounds, 700 pounds to those, which is really nothing compared to what the strut can actually handle. And there's guys that use these for overhead trolleys with hoists on them, and they're picking up, you know, a couple thousand pounds off 2 of those trolleys hanging from the ceiling directly down on them. So out of all the things that I'm worried about on this, which I'm really not worried about much, those are the absolute bottom of the list of things that I feel like would fail. Just the way that this gets loaded and the way the load distributes between it, I don't see any issue at all with that. Let's head up top and we'll check out the hoisting part. Okay, so up here, kind of the heart of this whole thing is the Vevor 2,200 pound winch or hoist. I got that from Vevor for 179 bucks. The next most important thing is this solid 1-inch shaft. It's got a 1/4-inch keyway in it. This is solid, it's not a hollow tube. And this is actually designed for commercial garage doors. And you can order them in different lengths. I ordered this through Menards. I got it at the 8'6" length. And it was $105 for that. What's holding that in place are these pillow block bearings. So these are 1-inch diameter pillow block bearings. There's 6 of them on here. There's 2 at each end, and there is 2 in the center. And I bought that for a set of 6 of those on Amazon. I thought it was a great deal. It was 35 bucks, I think, for those. In the center here, we have a 36 tooth sprocket with a 1-inch bore and a 1/4-inch keyway. You can see the keyway there that holds the gear in place, fits into the keyway. And that sprocket there was about 50 bucks. So on the hoist itself, we have an 18 tooth gear, and this is a W series hub adapter. So the gear fits onto the hub, and then you buy different size hub bores to fit the shaft that you have. And this was an 1 3/16 center bore with an 18 tooth gear. And you got to buy those separately, and they're both around $23 a piece. Out at the ends, we got our cable drums. So these are commercial door cable drums. They are designed for an 18-foot door, so even if you have 18 feet of cable peeled off of them, you still at least leave 2 full wraps on here. We're only using about 17 feet of it, so there's almost 3 full wraps left down there, which is good. They come as a pair. There's a right and a left, and those are about $43 each. I did buy some 1/4-inch keyway stock. I just bought a chunk of it, like a 12-inch chunk. That was like $7 or $8 for that. On the cable drums here, we got 3/16 cable that's actually approved for lifting. This isn't just like cable you'd buy at Home Depot. This is actually designed for hoisting applications. I ended up buying that through McMaster-Carr. I bought a 50-foot length of it, which was enough to do both sides. It was about $92. On the ends of those are these cable stud adapters, so it converts the 3/16 cable to a 3/8 stud, so you can put them through plate here, and then you have adjustment with the nut on the top and bottom. Those are also approved for lifting applications. It's not just something, you can find those on Amazon for cable railings and things, but they're not made to lift anything, so I wouldn't use those. So those also came from McMaster-Carr, and they were about $37 a piece. The other thing we had to use was some chain. So this is grade 80, 5/16 chain. I think I bought a 20-foot length of that for about $39. So there's quite a few guys that were concerned that if there was a chain failure that this platform would drop. And that is 100% true. If something was to happen to that chain or that gear, that sprocket up there, and it completely disconnected from the motor, then there's nothing no longer holding up this platform, and it would drop to the ground, which would not be good. So I'm trying to come up with a cost-effective, reasonable solution if that was to happen. Something either catches it. I could do a set of retractable lanyards like you'd wear on a fall arrest harness. I could put one of those on each side, and they act like a seatbelt. You know, as long as they're moving slow, they don't grab, but if you yank on the cable, they lock in place. So that is an option, but those are pricey. If you buy them new, you know, they could be almost $400 to $500, even more, depending on the cable length that you get for them. And I'm not saying that the safety isn't worth putting extra money into it, because it is important. But we also have to realize that this is a material elevator that's going to get very minimal amount of use. This is not a daily use elevator that's moving people up and down, going to work every day. This is simply here to take materials from my shop to my attic and back down. And that's really it. And once I get things kind of set up here, if it gets used once every 2 weeks after that throughout the year, I mean, I think that would be a lot. The right thing to do is never actually ride on the elevator. You know, put the materials on it, bring it up here, come up the stairs, and you know, unload the stuff. Is that what I'm gonna do? Probably not. I'm probably gonna end up riding the thing up and down. So that being said, I am gonna work towards a solution to put in some fail safes. I may add a second gear and a second sprocket, or a second sprocket and a second chain for a little bit of redundancy there. The cables already are redundant in a way to where if one was to snap, the platform would still stay. I mean, it would probably cock to the side a little bit, but being that it's squared in these trolleys here, it really can't rack itself very far. And one of the cables, the working load of the cables is well over 800 pounds a piece. The braking strength is 5 times that. So even if one was to break or something happened to it, the other one technically could hold everything on this platform several times over. The other thing is, yes, I did put basically 1,000 pounds of weight on this platform, and the platform itself weighs close to 200 pounds. So there was well over 1,000 pounds of load on that shaft and cables and hoist already. And that was merely to test it, to show that it's capable of that, and that the safety factors built into it, knowing that it can do that capacity in the daily use that I use it, or the weekly or monthly use that I use it. I'm in the 200 to 300 to 400 pounds, maybe max range. I'm well within its capabilities. So just the simple fact that everything up here can hold basically double or triple what I plan on using it at is a redundancy in itself. It's just like a cable on a crane or a strap on a rigging or a chain when they're rigging something. If that cable on that crane fails, it's going to fall. If that chain breaks, it's going to fall. But the safety is built into the factor of how many times stronger the braking strength is compared to the working load that's on it. So if everything fails at 3,500 pounds, let's say, and I'm using 400 pounds, the chances of it failing are very minimal. Not saying that it can't happen, because stuff does happen, and we definitely don't want that to happen. But so to say there's zero safety really isn't true, because the safety is built into the factor of the working load compared to the braking strength of the components. I do think it's plenty safe to use. I'm not really overly concerned about it, but I still will look for a solution that makes sense. All right, so let's move on. So onto the limit switch. So this is where I feel like I separated myself from pretty much every other lift system I've seen online. I know some other guys have done similar things where it winds up a shaft or a pipe, but I haven't really seen many people do a good limit switch system. I've seen a few where it comes up and there's a limit switch at the top. I haven't seen anybody put a limit switch at the bottom, and I have not seen anybody use a rotary limit switch like I did here. What I ended up doing was, this is a LiftMaster limit switch system, rotary limit switch system, and this was $169 just for this box here. And when you get this box, it comes with a little gear on it, like a bicycle size gear for a very small chain, and it's used for like a motorized gate, and the chain turns the shaft there. So I converted it to the timing gear style pulleys, and I believe I have a 18 tooth pulley down here, and I have a 40 tooth pulley up here. And actually I had to put a little reducer bushing on the shaft here because I couldn't find the 18 tooth pulley with a 3/8 ID bore in it. I could only find a 1/2 inch bore. So there's a little reducer bushing that reduces it down to 3/8. That's on there. This has a 1 inch bore, fits right on the shaft. And then we got the belt there. The smaller pulley was like $12. The larger pulley was about $20. The belt was about $10. The reducer bushings, I ended up buying a little set of them offline. I could have probably went to the hardware store cheaper, but I think it was like $9 for a 5-pack of those reducer bushings. The cord here, you need a 4 conductor cord. You need 4 wires to go from the box up to your controller. And I actually had this left over from my mini split system. I had a chunk of it, but if you had to buy, like, let's say a 15-foot chunk of that, probably looking at like $1 a foot or so for that. So maybe $15 or $18, however much you need to go from wherever you're going to mount your limit switch up to the control box. So anything left other than that really was just all the hardware. So I did use a lot of those like header lock screws, those big 5-inch, but I think they were 5/16 screws. And I used about 50 of those screws. I bought a box of 50 of them, and I think it was like $45 for the box. So they're not cheap, but I went through quite a bit of them. The other hardware was all the 1/2-inch hardware. So pretty much all the nuts and bolts on this thing is all 1/2-inch. I did use grade 8 fasteners. So you buy all that by the pound from, I think I got it from Family Farm at Home. And I think I spent about $42 on all the hardware for here. There's quite a few nuts and bolts and washers, and I probably got a few extra that I didn't need, but I think I did spend about $42 there on those. I haven't really done much up here yet. I'm going to put some railings up along the sides so the kids can't fall or anything if Tommy's up here helping me. Yeah, the limit switch works every time. It's exactly at the same spot. I've had 0 issues with that. So the only other things I ended up buying, the black and yellow stripe caution tape. I bought a roll of that for like $8, I think it was. The black paint, I bought that from the Tractor Supply, and that was $28 for that, for a quart of black paint. The last thing I actually had it was the carpeting, but if you wanted to get it, Home Depot sells it. I believe it's like $25 for a 6-foot by 8-foot roll of the outdoor carpeting. So the other comment I got from a few people was I should have put more supports underneath here as far as the tubing underneath the plywood. You know, I probably could have. I probably could have put 2 in there instead of 1. The main goal was to keep things as light as possible, because the less weight I add here, the more weight I can pick up without an issue. But 2, 3/4 inch subfloor, I know it's not supposed to span over 24 inches in, you know, a residential type situation, but I guarantee you I could put 1,000 pounds in the center of that thing and it would barely deflect, maybe 3/8 of an inch at the most in the center. And for what this thing's doing, it's more than enough. There's like no deflection. If I walk on that, it barely even moves. So I'm not at all worried about not having enough cross braces in here, because it definitely is plenty firm enough, plenty rigid enough for what it's doing. So guys, do you think it was worth the $1,600 I spent to build it? I think it was. I'm sure there were some areas that I could have, you know, saved some money on or made things a little smaller. I honestly don't have too much that I would have really changed with it. I know I was trying to mock up a little spring assist for the platform for lifting it up and folding it. And I still can always add that down the road. But for me, it's not a big deal to fold it down. It's just if my wife wants to use it when I'm not home, you know, she might have trouble lowering that down by herself, you know, the fold down portion of it. So I still might find a way to where, you know, I have some counterbalance or some springs or struts or something like that to help raise that back up. Maybe if I was to do it again, I would add a second chain and sprocket up there, just for a little redundancy on that. Since the cables are redundant, then the chain and sprocket would be as well. But as far as the way the strut worked out, the trolleys worked out, the way it folds up, the way the cable drums wind up the cable perfectly, the limit switch, like I said before, that's the best part, I think. I'm the happiest the way that turned out. If you guys don't get anything else from this video other than to use that limit switch system for your hoist, I think that itself is worth it. So yeah, that's about it, guys. I appreciate you watching. And if you liked what you saw, give me a thumbs up. Hit that subscribe button if you haven't yet. And we got plenty more projects coming, so we'll see you on the next one.